Hey guys, welcome back. Hopefully I'll see you guys tomorrow. It's been a while, almost a full week since we've seen each other. It has been a full week since we've seen each other. Too long. So hope you guys are feeling well. Hope your family is well. I was sick, but I am now feeling a lot better and I'm ready to go back to school. So the plan is hopefully we'll be back together tomorrow. Wednesday we'll go over the practice test. Thursday we'll take the test over similarity. So if you are behind, if you got sick, maybe you weren't feeling well like I wasn't feeling well, we need to get caught up. So as soon as you're able and you can focus, let's make sure we get through those assignments and those review assignments as well so that we're ready for this test when we come back. So I did not have you guys do the similarity quiz like I've done in the past. And when I do that, usually students find out that there's a lot of mistakes that we can make. So these are the top 3 most missed problems from the similarity quiz. I want to go over them with you because there's a chance you guys are going to make the same mistakes my students in the past did. So on number 1, 71.4% of my students missed this one in the past. If we're setting this up, a lot of you want to set this up that 4 is going to go to, 4 goes to 12 just as x goes to 9. But the problem with that is we have 2 different triangles. We can see they're similar by angle because this angle is congruent between them. But we have the small triangle, the green triangle, then we have the big blue triangle. And the issue is that we actually have to add these together. This 9 is an extension. Just like the extension we have on the top up here. Now those extensions are proportional to the other 2 sides of the triangle by the same scale factor with them. But the problem is whenever we're going from the small triangle to the big triangle, from the green to the blue, we have to use the other blue side, which is going to be found by adding these 2 together. So 9 plus 12 is going to leave us with 21. So when I set up my proportion, I'm going to go 4 goes to 12. If you notice, there's a scale factor between these 2, between those 2 of times 3. And so really if I divide 21 by 3, it would be 7. So you could see that. If you don't see it, that's fine. Just finish setting up the proportion. So 4 goes to 12, just as on the big blue triangle, we have x goes to 21. Now, because x is by itself, you can just plug this straight in the calculator is what I would do. When I cross multiply, I'm going to end up with 12 times x is equal to 4 and 21, which is going to be 84. And then we just divide it by 12. So the shortcut on that is just to multiply 4 times 21. And then we're going to divide that by 12 because it's going to be 12x, right? And that's going to leave us with 7. So we'll be doing that shortcut quite a bit today as well. You can set up the equation and do it however you need to. So remember, the extensions are proportional, but if we're finding the length of the big triangle side, like the blue one, we actually have to do that blue. Now, if I extended this over here, this part here would be that same proportion, which I think would have been 3. And if I add that to the original 4, that is how we get it up to the 7. So there really is 3 triangles in here that are similar. We have the small green one, the even smaller one, the extensions, which is the red one, and then we have the big one, the blue one, which is really cool. So hope you guys enjoyed seeing that visual there. Next one, we have 3 triangles again. These are all similar, side splitting theorem, because these are all parallel to each other, meaning these corresponding angles here, here, and here are all going to be exactly the same. So one length they give us is 10. That's going to be on this big blue, medium-sized blue triangle. So when I add those together, that base, just like we done the last one, is 8. And then the long one, the big triangle here, is going to be, when I add another 3 to it, it's going to give me a total of 11. So I know 10 is going to go to the 8, just as x is going to go to the 11. So I can set that up. Then when I cross multiply it, I'm going to have 10 times 11, which is 110, divided by 8. And that's what I'm going to end up putting in the calculator. So again, you can go straight to your shortcut and just do 10 times 11 and then divide that by 8. There we go. So 13.75. The next one, we have 2 triangles. They are going to be similar to each other. We'll have to actually check that by side, or side angle side, because we don't know this third side. So this is a right angle here, and what I want to do is I want to set up an extended proportion on this one. So the smallest to biggest is how I do it. So on my smallest triangle here, the green one, I have 4 and then 6, then 8. Then on the blue one, the smallest one is going to be 6, then 9, and then the hypotenuse, the longest one, is going to have to be the x. So that would be 6, 9, and then x. Now, to check to see if they are actually similar, I cross multiply, and when I do that, I get 36 and 36. So they are proportional by side angle side because we have the same right angle in between those 2. Now I can solve the other part to solve for the value of x. Now that I know all the sides have to be proportional. So when I do that, I'm just going to go straight to my shortcut, by the way. So I'm going to do 8 times 9. And then divide that by 6, which is going to leave me with 12. So this missing side here has to be 12. All right, so if you want to get out your assignment now, there's nothing new, so we're going to go straight to it. On number 1, the polygons are similar. Find the reduced ratio from figure A to B. So in this case, we're going from the right to the left, which is backwards from how we usually do it. That's why I had you label it. And the scale factor, then set up a proportion to solve for the missing value of x. So if I'm going from A to B, from over here to here, they're similar as appears, so they're not going to be flipped or rotated or anything. So 6 is going to correspond with a 9, so my ratio is going to be 6 to 9, which reduces to 2 to 3. Now if you put that in the calculator, it will reduce it for you if you do it as a fraction, if you're not confident with that. So 6 divided by 9 is going to reduce to 2 to 3. So my ratio is 2 to 3. So I'm going from the right to the left, so from the small one to the bigger one. Now the scale factor, we just take that ratio and we just flip it essentially. So it's going to be 3 over 2, which is 1.5 or 1.5. So what do you multiply 6 by to get it up to 9? It's 1.5. Those should both be on your answer bank, by the way. Now to solve for the value of x, we set up a proportion. So x is going to correspond with the 14 or the 9. It doesn't really matter how you set it up as long as you set it up consistently. So x goes with the 9 just as the 14 will go with the 6. So top to bottom, top to bottom. And then I can cross multiply again. It's going to give me 6x is equal to whatever those two multiply to. So I'm just going to go ahead and put that in the calculator. So it's going to be 9 times 14 and then divided by 6, I believe, yeah. Okay, which is going to be 21, sure enough. All right, so that's number 1. Let's look at number 4. Again, we're going from the right to the left on this one because it's going from A to B. So I'm going to get 2 corresponding parts. I don't know what the 20 corresponds with, and this 20 goes with an x term, so the only ones I really have are the 30 and the 24. So 24 goes to 30. I can pull 6 out of both of those, or if you're not sure, just put it in the calculator. So 24 over 30, which is going to reduce by pulling a 6 out of both of them to be 4 over 5. So my ratio is 4 to 5. The scale factor, we just flip that fraction. So 5 over 4, which is 1.25, I believe. And then to solve for the value of the x term, I'm going to have 4x minus 3 goes to 30, just as 20 goes to 24. So 20 is going to go to 24. Now the next step is I want to reduce this as much as I can before I cross multiply, because I don't want to have to distribute the 24 through to both of these terms. It's going to make the numbers really, really big. So I'm going to reduce this part first. So 20 and 24. I can pull a 4 out of both of those, which is going to be 5 and 6, so 5/6. So that will reduce to 5/6. The next step, I can actually reduce across, so 30 and 6, I can pull 6 out of both of those. That'll leave me with 5 and 1. Yeah, so now when I cross multiply, what's wonderful is it's 4x minus 3 times 1, which is just 4x minus 3. So I don't have to distribute anything through there. And then 5 times 5 is going to be 25. So now it's just simple algebra from here. I know there's not a whole lot of room for you guys to write on that, so I'm sorry. I'm going to add 3 to both sides, which leave me with 4x is equal to 28. Then divide by 4, so I have x is equal to 7. On number 5, we have 2 similar triangles. They're saying that they are proportional as they appear, so you don't have to prove they're similar. We just have to set up a proportion and solve for the missing one. So we have 2 different triangles. We have a small green one, and we're going to have the big blue one. Now they're not giving us the extension, so we don't have to add those together. It's already the full length side of 9. That's why we have this measurement line here. So 6 goes with that 4, just as the 9 is going to go with the x. When I cross multiply, I'm going to get 6x is equal to 36. And then just divide for 6 both sides, so x is equal to 6. So not too bad. Again, you can do, just plug it in the calculator if you want. We don't need to spend any time reducing these because the x is already by itself, so the calculator will do all the work for us. It's only whenever we have an expression, just like on this one, we're going to want to reduce it first. Okay, so this is an angle bisector. Angle bisectors split the opposite sides in proportions to the other 2 sides. So what we really do need to find is this red length here. So we're going to have 2x plus 4 goes to this 15, just as the 6 is going to go to this red part here. So the problem with that one is I have to subtract these 2. So the full length is 15 minus this 6 is going to leave me with 9. So this part here is going to be 9. All right, now I'm going to reduce these fractions before I cross multiply. Otherwise, I'm going to have to distribute the 9 through to both of these terms. It's not the end of the world, but it's going to make our numbers a lot bigger. And I like to work with small numbers. So let's reduce beforehand. So this looks like 2/3 to me. And sure enough, it is 2/3. Then 15 and 3 can be reduced to 1 and 5. So it would be 1 and 5. Yep. All right, so now when I cross multiply, again, it's going to be 1 times 2x plus 4, which is 2x plus 4, and 2 times 5 is 10. So subtract 4 from both sides, 2x is equal to 6, and then divide by 2, leaving us with x is equal to 3. So very similar to the last one we did, really. All right, number 8. State if the triangles are similar. If so, state the postulate used to prove that they are similar. All right, so on this one, I don't know any of my angles. I don't have vertical angles, parallel lines, alternate interior, anything like that. So, but I do have all three sides. So I will prove this with side, side, side. Remember, we go small, medium, large. So the smallest one before the dilation is going to be the smallest one after the dilation. So 15 is going to go with that 40. And then we had 18 and 27. And then medium and large would be 48 and 72. Now we're ready to cross multiply to verify and check to make sure that these actually are proportional. So I'm going to put them in my calculator and see what I get. So 15 and 48. So 15 times 48. And then 40 times 18, and those should be the same. They are, but it's not enough just that two sides are proportional, they all have to be. So now I need to cross multiply the other two parts. So let me clear this out real quick so it's not too confusing. So I have 18 times 27, and then 48 times 72, or 27. Wow, dyslexia is the worst. All right, those are exactly the same as well. So I know that they're proportional. They're all the same fraction. They also reduce to the same fraction, but I'm not going to go through that effort there. So are they similar? Yes. By what postulate? We did side, side, side. All right, number 10. So on this one, I do not have all three sides, but I do have an angle. So if you look at the diagram, I have a vertical angle in between those two. So I'm going to be solving this with side, angle, side. But I do have to check that those two sides are proportional. So I got to set up a proportion. The tricky part on this one is knowing which ones correspond with each other. And so the only rule we can really follow is the smaller one goes with the smaller one, the bigger one goes with the bigger one. So the smallest I have on this side is the 36. The smallest one I have over here would be the 14. So the 36 goes with the 14, just as the 51 goes with the bigger one of 20. So 36, 14, the bigger one of 51 goes with the 20. Now when I cross multiply these two, we're going to find they're not actually going to be equal. They're really close, but not quite the same. And so they're not going to be proportional, so these triangles are not going to be similar. So are the triangles similar? It's going to be no. By what postulate? We use side, angle, side. Number 18, again, I've got two triangles. I got the small green one and I've got the big blue one. I don't have to worry about this extension because it's already added to the 12 to give me the full 28. So I can set this one up just like you want to. So the 9 goes with the 12, just as the x goes with the 28. And then we cross multiply. That's going to be 9 times 28 divided by 12, which is what those are. We divide by 12, and it leaves us with 6. So x is going to be equal to 6 on that one. 24 and 25 can be a little bit tricky. These are just theory questions. So we have two triangles that are similar. They ask true or false. The perimeters of the similar triangles are the same ratio as the corresponding sides. So the perimeters when we add up all the sides. So if I add up all the three sides I have here, 3, 4, and 7, that's going to leave me with 14. So the perimeter is 14. And over here, whenever I go from 3 to 6, I'm doubling all the sides, right? So 6, 4, and 7 are all, so 3, 4, and 7 are all doubled to 6, 8, and 14. So my perimeter is going to be doubled as well, essentially. So that's going to be 28. So yes, the perimeter is going to be the exact same ratio, 1 to 2 in this case. So that is going to be true. The altitude, so the altitudes are the heights of the triangle. Remember, if we dropped an altitude by doing our kite construction, if that's going to follow the same scale factor too. So if this is 3.5, this one over here is going to have to end up being 7. So the altitudes are going to be the same proportion as well. So both the altitudes, the perimeter, any one-dimensional length will be the same scale factor. It's whenever we start getting into two-dimensional or three-dimensional lengths, such as area or volume, that the scale factor is going to be squared or cubed. But we'll get into that. It's actually like the last lesson that we'll learn in all of geometry, but it's kind of cool, dimensional stuff. All right, number 30, this is a indirect measurement. So all the rays coming from the sun, at least the ones that hit us because we're so far away, are all going parallel to each other. The ones that are not parallel, we don't see, they go somewhere else in the universe. So hitting the top part of the flagpole at the same time is going to cast the same angles in the shadow as the part that's hitting the top of your head or any other object. So if I measure your height and your shadow, it's going to be proportional to the height of the flagpole and the shadow that it casts. So the problem we actually have have on this question is that we are going from feet to inches on the same length. So we want to convert this from feet to inches. So I'm going to multiply it by 12, right? So 27 times 12 is going to be 324. So now this is converted to inches. I'm going from inches to inches, feet to feet. Now that's fine as long as the corresponding ones are in the same units. There's our scale factor is not truly the well, no, scale factor is the same. It's just the two units are being measured differently, which is okay. So I have 324 goes with 54, just as x is going to go with 6. So we're doing x feet and 6 feet here. So these are in inches, and this is also I'll have to fix that, but that's inches as well. So we're fine. We can cross multiply. It's going to give us 54x is equal to 324 times 6, which is 1944 apparently. Then we divide that by 54, which is going to leave us with 36 feet. So this height here is going to be 36 feet. The scale factor is going to be times 6. So if I do 6 times 54, that'll give me up here. 6 times 6 would give me 36 as well. So basically the flagpole is 6 times taller than you are, so its shadow should also be 6 times longer than your shadow. Number 31, indirect measurement, just like the last one. So as long as these measurements are being taken at the same time, they're going to be similar, and the sides will be proportional. So we have 12 feet goes to x feet for the height of this flower, the shadow of 24 feet and 42 inches. So it's okay as if both of these are in feet and both of these are in inches, that should be fine. It'll be the same scale factor between them. It's actually going to be 12 times bigger than whatever we thought it was, because we're converting not just from feet but also to inches as well. So that's going to be 12 goes to x, just as 24 goes to 42. Because if we change both of these to inches, we'd just be multiplying them both by 12, and it's going to be the same ratio and the same scale factor, essentially just 12 times bigger than what we had over here. So when I cross multiply, I'm going to get 24x is equal to 504 divided by 24, which leaves me with 21, and that should be right. Also, if you see the scale factor here, it's just half, right? So the length of the height of the flagpole is half of its shadow. So if this shadow over here is going to be 42 then inches, then this should be 21 inches as well. So anyway, kind of a cool way of looking at that one. Number 34, we've got our side splitting theorem here. So we see these two are parallel, so those angles, corresponding angles, are congruent. We have our small green triangle and then 2 extensions. Now this is not a problem that we're both dealing with extensions. The only issue would be is if we're trying to solve for this big blue length over here, then we'd have to add those two together and get 12 and go from there, but we don't have to do that. So 5 goes with the 8, just as the x goes with the 4. Then when we cross multiply, we get 8x is equal to 20 divided by 8, which will leave me with x is equal to 2.5. So on number 36, we do have parallel lines, which is important because we're going to have two angles that are the same. We're going to have vertical angles, and then the alternate interior angles are going to have to be the same as well. Now that's going to help us identify how to set up our proportion, because again, we know the smaller one, 16, goes with the smaller one, wait a second, is 10 or x smaller. We don't know because x can be anything. So we can't just set up this one with a smaller and smaller with the bigger one with the bigger one. Instead, we have to look at the corresponding parts between the side that's included between two of the same angles. So the two angles we have here are the same as these two angles here, which tells us that the 18 has to correspond with the 10. So 10 goes to the 18, just as x will go to the 16. So as x goes to 16. So a little bit tricky, and if this was a question on the test, probably a lot of you guys would miss that one because we haven't talked about how to do that one yet. But now you know, so I'm glad you're watching the video, right? So we have 18x is equal to 160 divided by 18, which will leave us with 8.8 repeating decimal there. All right, that's it. So if you have any other questions, you can send me a message on Google Classroom or on Remind. Hope I see you guys tomorrow. We should be back. I think it was just 2 of our schools that were out just today, and they're trying to get us back in school. So hopefully I'll see you guys tomorrow for the practice test, and we'll take the test on Thursday. Then we're going to move on to my favorite unit, which is right triangles. So really looking forward to that. Have a lot of fun activities that I'm looking forward to going through with you guys. So see you guys later. I hope you guys have a good day. Bye-bye.